I welcome everyone for this video lecture. This video lecture is about the hardware architecture for parallel processing. So this is a topic we are discussing from Unit 1, that is the Introduction to Cloud Computing. Under the Introduction to Cloud Computing, we are going to see the hardware architecture for parallel processing. We already know what is meant by parallel processing. A task is processed how? In a parallel way. So, what are the hardware architectures that can be used for doing that parallel processing we are going to discuss. So, in parallel processing, CPU, the processor is the main important component. So, why we talk about the processor unit is the important component? Because it has the main role, or we call it as a responsibility for executing a task. Task in the case it has a main task and it has a subtask in the program. So the program consists of different streams. We call it as an instruction stream and data streams. So the each and every program will have a instruction set of instructions and set of data. So we call it as an instruction streams and data streams. The instruction streams and data streams are watched by a CPU during an execution of the program, that is during the task execution. Therefore, the hardware architecture for the parallel computer is categorized by Flynn classification method. They have classified a method how this hardware architecture will be. Flynn's classification for parallel computers, that is for parallel processing. Parallel computer is nothing but a parallel processing, how they are going to process. I told that in parallel processing, each program will have a different instructions and different data streams. So we will be combining the instructions and data stream. First one is the SIAD, that is single instruction stream and single data stream. Next one is SIMD, that is single instruction stream but multiple data streams are there. Next one, multiple instruction stream and single data stream. Followed by the fourth one, multiple instruction stream and multiple data stream. So the instruction stream and data stream will be having a single, multiple, multiple, single, multiple, multiple. So this is why the Flynn's classification is done for parallel processing for the execution of the program. That is, we call it as a task, processing of task. So let us discuss about the SIST, that is single instruction and single data. So how the stream of instructions and data are performing their task with the help of CPU. So we call this as a serial, and it is a non-parallel computer which executes the single instructions over the single data stream. And single instruction means only one instruction stream is being acted on the CPU. While a single data means that only one data stream is used as the input during one clock cycle. So you can see in the architecture diagram, you can see there is only one single instruction from the instruction pool, that is set of instruction pool and set of data pool. Only one data, one instruction will be given to the processor to executing the task. This is called a single instruction and single data pool. Here we call it as a single instruction and multiple data. So from the set of instruction, we will be having only single instruction. From the set of data, we call it as a data pool, we will be having a multiple data. It is not a serial, it is a type of parallel computer in which all processing elements execute the same instructions at a given clock cycle, and each processing element operates on different data element. So all the processing elements will receive the same instruction broadcasted from the single unit, as because there is only one instruction, but the data can be different. You can see the architecture diagram. You can see A single instruction is given to n number of data pools. Multiple data streams are coming from data pools, but a single instruction which is from the instruction pool has been given to the processor 1 and processor 2, processor 3, processor 4, followed by data pool 1, 2, 3 and 4. You can see only one line, that is we represent only one line from the instruction pool. That is single instruction is given here, the same instruction is given here, the same instruction is given here, the same instruction. But here it is an one data pool, it is another data pool, it is another data pool, it is another data stream. So it is in multiple data streams which act for a processor which will be dealing with a single instruction. This is called SIMD. So each processing element takes a data from its own. It is best suited for specialized problem categorized by high degree of regularity such as graphics and image processing. We will be using it. That is multiple data and single instruction. This is SIMD. Next we go for MIST. That is multiple instruction and single data. In this type of parallel computer, multiple instruction over a single data stream. So you can see the diagram here, where the instruction is multiple. One instruction and another instruction. But the data pool is single. Single data pool will take care of this instruction processor with this instruction, and the same data pool will be taking care of the next instructions for the selected set of clock cycles, and it completes. That is a single data pool, and which have a multiple instructions of stream. Multiple instructions and single data pool. Next one is a multiple instructions and multiple data. This is the most powerful parallel computer in which each processor will be executing a different instruction stream on different data stream. As MIMD computers are able to run independent programs, many tasks can be performed at the same time. So, for example, 5 tasks are there, we can have schedule 5 tasks for individual instruction and individual data pool. So you can see these examples of MIMD are multi-core computers, multi-processor computers and network computers, clusters and supercomputers. You can see the architecture. This is the architecture where you will be getting 2 set of instructions, and 2 set of instructions will be followed by 2 set of data pool. See here, this data pool is setting with this instruction, and this separate data pool is setting with this instruction. So multiple instruction, multiple data stream. So this is called as an MID. These are the hardware architecture for parallel processing. Next we go for a shared memory architecture called parallel processing. How the memory is shared? It depends on 2 types, uniform memory access and non-uniform memory access. So uniform memory access comprises 2 or more processors with identical characteristics. UMA architecture, also called symmetric multiprocessor. The processors share the same memory and are connected by bus shared interconnection scheme such that memory access time is almost same. You can see the diagram here. It is an IBM S90. It is an example for uniform memory access because the memory is accessed by 4 set of processors in a uniform manner. So this is called as a uniform memory access. When we go for non-uniform memory access, it uses one or more symmetric multiprocessor or physically linked. The burst of memory is allocated with each processor. So each and every processor, some set of memory is allocated. So here the memory is not allocated. Uniformly all the CPU will have access of this memory, but here the memory is allocated. Therefore access to the local memory becomes faster than the remote memory because we have allocated the memory, so local memory will be faster than the remote memory. In mechanism, all processors do not get equal access time to the memory which is connected by interconnection network. Therefore the memory across the link is very slow. See here, we have allocated a memory to a bus interconnected. See, this processor, 4 processor will be having a memory. This 4 processor will be having a memory. This 4 processor will have a memory. This 4 processor will have a memory, and each unit is bus interconnected. So we have all the memories will be allocated for each and every processor. So the local memory will be faster than the remote memory. Thanks for watching the video. In this video, we have clearly described about the hardware